Okay, guys. Hey, I'm filming for my A cohort. I have the B cohort here. What we're going to do today, guys. So this is Thursday, and I ended up had a little emergency room visit. My wife had her appendix out. She's fine now, but I ended up needing to take care of her a couple days. Okay, I am on this lab that's the Redox titration lab. And what I want to do today is I want to do the part A on that. We're just going to do that as a class. So again, my cohort A, you guys are going to have the same data for part A. And then on Monday, Tuesday, you guys are going to do part B. Okay. So the purpose in this lab, and I do want to talk a little bit about the chemistry of this. But the point or the purpose or the problem where it says experiment overview at the bottom, you can write in the problem right here. So you guys can write that in here. And so when we're all done with this lab, what you're going to determine is the percent iron in an unknown containing salt. So you, again, I would write that right down here where it says experiment overview. Did anybody need this? You all good with this? Okay, so at the bottom, right here at the bottom, what is the percent iron in an unknown containing salt? And so this, and I don't know, you guys can see that, but you can see it's just a green solid. This has iron in it, and we're not going to deal with this today, but next week we will, and we're going to use that oxidation reduction principle that I talked about in the notes, and it's really important right now to be watching those notes. We're definitely getting to the place now where you really need to be watching the notes. So what I did is I weighed out, so here's the data. So on the, in note 2 on the back, and for right now, on the back of the first page, it says pre-lab questions. You probably want a separate piece of paper to do that. And that might be better to do after we do the stuff next week. But there are pre-lab questions. But for data, it says on the second page, construct 2 data tables. So I'm going to kind of give you some direction. So here is the data table for part 1. And again, we're just going to do one trial and kind of walk you through this. I've already weighed out the oxalic acid and the initial volume, the final volume we're going to get. And then for part 2, we're going to come in on Monday, Tuesday, and we're going to do that. And I'll kind of walk you through that. In a normal year, when we have blocks, I always, with my students, this lab would take a whole block. And I mean, we get started right away. And matter of fact, sometimes there would even be where it would kind of go leak over into my, into where I have to write them a pass. But what we're going to do is we're going to do part 1 today as a class, and then we'll do part 2 in your group on Monday, Tuesday, and I'll talk a little bit about that too. And also, and I've got right over here, so you guys can see this, here is kind of what is going on. We are almost to fall break. We have 2 weeks. In that time, nothing is due on Monday, Tuesday. So Monday, Tuesday, I want it to be a time too where you come in, and Alan was asking me some questions, Jonah was, to go over your questions, but we're going to do lab, and I'll come around and try and help you with questions. And if you ever have questions, feel free to email me. If I can't answer that, we'll do a Google Meet. But nothing due Monday, Tuesday. But on Wednesday, Thursday, the gravimetric lab is due. And you might have questions. Both of you guys had questions on that today. The quiz for Chapter 4 is due the following week on Monday, Tuesday, October 5th or 6th. This lab that we're starting today is going to be due on Wednesday, Thursday, 2 weeks from now. And then remember, test. Test is going to be, it's going to be a 2-part test. The first day will be the 5th or the 6th. The second day will be the 7th or the 8th. And I'm going to give you some review stuff for that. And I really want to set it up so so next Wednesday, Thursday is just going to be a day for you guys to ask questions. Just a day for you guys to on what we're doing. Okay. Okay, so I'm going to bring my computer over here. So something that happened last year because of the pandemic, this will make everybody dizzy that's watching this video online. But one thing that we always do, and if you had chemistry 2 years ago, you would have done this, but last year we ran out of time, are these long skinny tubes, which you guys are going to use next week. They're called a burette, and they're used because they have, you can add a little bit at a time. One thing that's really confusing, and so about these is the way they number them, and you guys will see this next week, but this is a 50 milliliter burette. And it's off here now. And you would think 50 is up here, and you think 0 is down here. But actually, if I had Kylie or Alan look at this, 0 is up here, and 50 is down here. And the way we're going to measure this, so I'm going to pour it here, and this is called potassium permanganate. And I have a big old flask of this that you guys will use. It looks like grape juice, kind of. But I'm going to pour it in the burette. And this lab is one you've got to wear, and this will be the case on Monday, Tuesday, is you've got to wear your goggles and you've got to wear an apron. This stuff is kind of messy. But I actually go above the top level. And if you read the procedure here, I've already done, and I'll help you guys with this on Monday. But Monday, Tuesday, is we need to clean this out. And I'll get some distilled water and we'll just clean this out. But I can just, with this little, it's called a stopcock thing, I can just run some of the liquid out of here. Okay, so now we're going to make our initial reading. So the initial reading, and again, following the rules of sig figs, this goes to the 10th, so I would want to go to the 100th. So I'm going to say 0.35. So I'm going to write that down up here. Tell you what, I'm going to actually change that just a little bit. I just want to get one more sig fig. So let's go 2.10. So, and I'll show you guys on my A cohort here in a second, but the initial volume of the KMNO4 is 2.10 moles. Part of the chemistry here I'm going to talk about next week. But what I'm going to do then is I'm going to take this and reading in the procedure. And I've already done, I've done this where I did step 3. I rinsed it with distilled water. I've added the KMNO4. I just did that. I did step 7, and I did the oxalic acid. I weighed out. It's actually 0.1993 grams. And then if you look on step 8, I put it in distilled water. I put it in sulfuric acid. And now I'm just going to add, like it says in step 9, I want to slowly titrate with the KMNO4. That's the purple stuff. And until we get to a faint pink color. And I know that I did this actually, I did this period 1 before I had class, and then I did this in period 2. It's going to take about 25, at least 25 mils. So if you're doing this the first time, you would just add a little squirt at a time, and it would take you a while to do. But because I've done this, I'm just going to add, whoops. Oh, there we go. It went away. Okay, so I'm just going to add, and this is why it was unfortunate that last spring we did not get to this, and so you guys can see this. So I add this, and what the classmates are seeing is they see the color, but I want it to go until it remains. And what's going on here is it's being neutralized, or a reaction's going on, and I want it to go until I get to a faint pink color. Chemistry is colorful. My color, Mia, I think it's colorful. And you guys can see that it continues, that color continues to go away. And I want to look for myself. I need my glasses on. Okay, still think I need a little bit to add a little bit more. Because I think I need at least 25 mils, and I'm not quite there yet. Closer, I think. Okay, it's getting closer. And one source of error on this lab is always the color. Let's try and get it. I think I'm getting pretty close to him. Trying to get to that faint pink color, almost there, I think. Close. And this is the advantage of the Duret. You can add just a little bit at a time. This lab, a titration, is one of the most common labs done in all of science. Almost, Kylie. And you guys are going to do something like this on Monday, Tuesday. Almost at it, Brandon. Okay, I think I got there. Okay, so there's a light pink color, and this is where sometimes maybe it's too dark, and you can see what happens. But I think I'm close to it. I think I'm going to stop there, and I'm going to read the volume now, and it's, we'll say 34.35 mils. Okay, so that'll be the final volume collected. What did I say, Kylie? 34.35 mils. Okay, so everybody's dizzy, so 34.35 mils. And again, if we had more time, we would do 2 trials, but I think this data is going to get us good enough results on that. So, okay, so if you read real quick, let me just talk to you about the procedure in part 2. So if you go to part 2, so when we get here, we've done part 1 now. Part 2. So what you're going to do, and I'm going to try and do 1 trial just for the sake of time. But step 1 says, and I'm going to have out the iron sample backed by both balances, and you're going to weigh it out. It says about 0.5 grams. And again, you got to wear an apron. You got to wear your goggles. You're going to get 60 mils of distilled water, 30 mils of sulfuric acid, which I did today. But we're going to add to this 2 mils of syrupy phosphoric acid. This is going to be not diluted at all. And I'm going to show you how to get that with a pipette on Monday, Tuesday. And we're going to do that in the hood. But you definitely want goggles on and apron. And then this one will just be at room temperature, so you don't need to heat it. And it's going to be the same idea. You're going to have the initial volume and the final volume. And again, if we get in the ballpark on trial 1, we won't do trial 2. I will tell you that I think you need to add at least 12 milliliters. And you might want to write yourself a note. You're going to need at least 12 milliliters to do that. So, okay, so I'm going to leave that for today. I want to come back a little bit later in class and talk about that. Okay, what I want to do now, because I want to, if you guys, I know you guys have some questions, and give you guys some time to work on things, but I want to go back to the notes a little bit, and I want to work a couple things, and I keep saying the same thing, but if you guys are not doing the problems that I ask you to do, or I'm watching the videos, we are now definitely getting into a place where we're doing new stuff. And if you are not doing this stuff, it's going to be a struggle. And we got 2 weeks. We got a test in those 2 weeks. Okay, so I want to go back to some of the notes that I gave online. I can hardly do this when I'm doing this here by myself, let alone with. Okay, so first of all, and and again, if you've watched this if you've been watching online, and again, I'm hoping you have, but I wanted to do a couple problems with this. So assigning oxidation numbers. And these were the rules. And again, I talked about this if you watched my videos. And this is something that you've got to be able to do. And I want to do a couple problems like this today, because this is going to be important in going to where, like on this lab, being able to do oxidation reduction problems. But again, I went over this online. And I really think that about half to 2/3 of you guys are watching these videos, but there's some of you that are not. And if you do not, did you see what happened to Drew Locke last week? He got smashed. That will happen to you before fall break. You will get the Drew Locke. You'll be on injured reserve. You'll be out for 3 weeks, okay? Be studying. We'll work up to fall break, and then fall break we will take off. But in doing oxidation reduction reactions, here are the rules. This is the steps I do. I always put these two together. And what I say is whenever you have an element by itself, its oxidation number equals its charge. Okay, so if something by itself, its oxidation number equals its charge. Then I skip down here to rule 4, and which for me is rule 2, is oxygen in a compound, its oxidation number is -2, which is easy because oxygen's ionic charge is -2. Now there's an exception here, and that is in the case of a peroxide, which in first year chem, we said, don't worry about. And of course, last year was a different year. Usually we always do this fairly well. But last year, because of the pandemic, we didn't. But the exception never comes up in first year chem. But in our class, it could. Like in hydrogen peroxide, H2O2, that would be an example, and then OF2. So first rule, something by itself is its charge. Second rule, in a compound or an ion, when it's combined to something else, oxygen almost always is -2 unless it's a peroxide. Then the next rule is hydrogen in a compound is always +1. And then the sum of the oxidation numbers equals the charge of the molecule or ion. And then this is kind of my last rule. Is the last thing I do is I use the charge of one of the parts. Okay, so I wanted to, and if you guys were following along, and I'm going to go back and forth here, is there was a couple that I had in the notes that I said I wanted you guys to do. So I'm going to do those right now to try. So what we're doing is we're doing oxidation numbers. So what I said is SO4 -2 and Na2CO3 and HPO4 -2. Okay, and what I wanted to do here was assign oxidation numbers for all the elements. So here, in SO4 -2 and sulfate, I know oxygen is -2. That's one of my rules. Oxygen's -2, and there's 4 of them, so it's -8. So each individual oxygen is -2, but overall it's -8, and it needs to total the charge, which is -2. So I call this fill in the blank. So what in a -8 equal -2? Well, that has to be a +6. So the oxidation numbers in sulfate, sulfur is positive 6, oxygen is negative 2. Okay, and sodium carbonate. So I'm actually going to do oxygen first and then sodium and then carbon. So I know oxygen, again, in a compound or an ion with something else is negative 2. So negative 2 times 3 is negative 6. And this has no charge, so it needs to total 0. Then what I do is I use sodium's ionic charge, which is positive 1. So positive 1 times 2 is positive 2, so fill in the blanks. So what's carbon? It has to be a positive. Again, what I'm doing here with the process that this is called is assigning oxidation numbers. Okay, so then in this one, this biphosphate ion, it needs a total negative 2. I've got oxygen, I've got hydrogen, I've got phosphorus. So oxygen, again, negative 2. This needs to total negative 2 overall because it's a negative 2 charge. Oxygen, negative 2 times 4 is negative 8. I know when hydrogen is combined with something else, it's positive 1. So then it's a fill in the blanks. So what? Positive 1 and what? And negative 8 equal negative 2. Alan, that would be a positive 5. Okay, give me thumbs up. How are we doing on oxidation numbers? We're doing okay on that? Okay. So I wanted just to make sure of that. Okay, sorry guys. My period 4 class is being patient with me here. Mr. Witt, the challenge guy. Okay, then the next thing to do, and again, I want to do a couple of examples of this, is something that we did not do in first year chem, which was doing the half reaction method. Ryan, did you do the half reaction method in your chem?
I have to see it.
You have to see, well, you're going to see it. We're going to do some now. Okay, so then I defined oxidation reduction. Again, I went over all this in the notes. And if you haven't seen the videos, they're still posted. And I really, again, the next 2 weeks, we need to really work. And then fall break, we'll give up. But I went over all this. And I had these little easy ways to remember things. Leo the lion goes grr. Loss of electrons is oxidation. Gaining electrons is reduction. Oil rig, oxidation is loss, reduction is gain. Okay, so I went over that page. But this is the page I want to talk about. And I was thinking, Mia, Kylie, Ryan, you don't have to answer, but do you think I should do that to my hair? No, you don't need to answer, like I said. Obviously, see, I got a smile on my face. Okay, this is what I wanted to talk about. I want to do 1 or 2 examples about balancing reactions with the half reaction method. So let me just put this up, and I want to do 2 examples, and this goes right along with the lab. So in doing these, and again, all this I've talked about online, but this is definitely going into new territory. And all this is on my website. You can see these notes. The first thing we do is we assign oxidation numbers, and we figure out what's been oxidized and reduced. And again, I want to do 2 examples. Then we're going to write half reactions for what's been oxidized, what's been reduced. And then a little bit different than normal balancing. Then again, we're going to balance all the elements except O and H. And then we're going to balance oxygens with water, and we're going to balance hydrogens with H+. And then this step 6 is where I always break down. And this is where I add electrons to balance the charge. And then I want to get the electrons equal on both sides. And then I add everything up. Okay, so, and again, if you guys can see this on online if you go there and okay, so oh, now I messed up. Okay, so I want to do an example of one, just working through one here. So, and then I want to do one that goes right along with the lab. So here's what we're going to do is we're going to balance this using the half reaction method. You balance this using the half reaction method. So this is the reaction. that we're given. So we're given Cr2O7 negative 2. Alan, this could have been the one on the quiz. Y'all can tell me. Well, Cl negative 1. Yeah, I just told Alan, I think this one's on the quiz. Cr plus 3 plus Cl2. Is this the one we talked about on the quiz? Okay. So step 1 was I assign all the oxidation numbers. So I do what I did over here. So here, I know oxygen's negative 2. I know this needs to total negative 2 because the charge is negative 2, so negative 14. So fill in the blank. So chromium would be a positive 12. But there's 2 of them. So how much is each chromium? 6. Okay, so there's oxidation numbers here by itself. Something by itself equals its charge. So chlorine is negative 1. Chromium is positive 3. And chlorine is 0 because it doesn't have any charge. And then if I look here, the chromium went down, which means it was reduced. And really, this is the way I always remember this. I go shopping at Walmart because Walmart reduces their prices. Well, reducing their prices means the prices go down. The same principle here is another one down, was reduced. Oxygen didn't, or oxygen's not even over here, but chlorine is. It went up, which means it was oxidized. So that's always my first step, is I figure out what's been oxidized and what's been reduced. Now I write out the half reactions. So I have Cr2O7 negative 2 to Cr positive 3. And then the Cl negative 1 to the Cl2. So those are my half reactions. Okay, now I balance all the elements other than O and H. So here I've got 2 chromiums, so I need a 2 there. I have 2 chlorines, so I have 2 there. So I balance all the elements other than O and H. Now, something we never did in first year chem is the way we balance oxygen is with water. So there's 7 waters here, or I mean 7 oxygens here. So I'm going to put 7 waters there. Okay, what that gives me is it gives me 7 oxygens. So I balance the oxygens with water. Weird thing, but that's how you do it. Here, there's no oxygen, so I don't even need to worry about that. Okay, then I balance the hydrogens with H+. So 7 times 2 is 14, so I have 14 H pluses. But again, there's no hydrogen there. Okay, so I look at the reaction, I figure out what's oxidized, what's reduced. Then I balance, then I have 2 half reactions. Then I balance the half reactions. First of all, I balance all the elements other than O and H. Then I balance oxygen with water, and then I balance hydrogen with H+. But this is where I always screw up, is balancing the charge with electrons. So I've got 14 positives and 2 negatives, 14 positives and 2 negatives. So I have a net positive 12 on the left side. 2 times positive 3 is positive 6, so I have positive 6 on the right side. So that means I'm going to put 6 electrons here. That balances the charge. You remember doing this? Okay, and this goes along with reduction. Remember, oil rig, reduction is gain. Now here, on this one, I have negative 2, so I'm going to have to put 2 electrons there. That's oxidation. Okay, so I balance the charge with electrons. Okay, now I want to get the electrons equal because I want the electrons to cancel out. I'm going to add this up. So to get the electrons equal, if I have 6 here and 2 here, what I'm going to do is I'm going to multiply this through by 3. 3 times 2 is 6. The 3 goes here, 6 there. And again, the reason I did that was to get 6 electrons, so I have equal electrons on both sides. Now I just add everything up, and if there's something common on the left and the right, I cancel it out. In this case, the only thing is the electron. So what I end up, so here is my overall reaction. 14 H pluses plus Cr2O7 negative 2 plus 6 Cl negative 1. Okay, then what's on the right is I have 2 Cr positive 3 plus 7 waters plus 3 Cl2s. And everything should be balanced. So I have 14 H's, 7 times 2, 14 H's, 2 chromiums, 7 water or 7 oxygens, 6 chlorines. The charge should be balanced. So I've got 14 positives, 2 negatives, so that's negative 12. So negative or positive 6, everything's balanced. That makes sense, Alan? Definitely got to be able to do this on our test. Okay, now on the lab. So on the lab, what I just did over here was, and actually if you look on this pre-lab, it's the first reaction, like you could ask a great question. You go, wait, we got potassium permanganate. Well, because of the potassium, it breaks down. And see, potassium is always going to be a spectator ion. So potassium, sodium, whenever you see those, they're a spectator ion. So you're going to get rid of those. So this is going to be the half reaction. So we have MnO4 negative to Mn plus 2. So, and they actually discuss this right on the front of this right here. And then what I did is I added it to oxalic acid, which this I would have to tell you. So this is going to walk you through part 1 of the lab. So I have the half reaction. So now I'm going to go back and do my rules. So I'm going to balance all the elements other than O and H. So Mn is balanced, but 2 carbons here, so I need a 2. Okay, then I'm going to balance oxygen with water. So 4 O's here, so I'm going to need 4 H2O's there, so I have 4 oxygens. Now here I have 4 oxygens and 2 times 2, 4 oxygens. And this guys, is the oxalic acid. It's a white solid, and I weighed it out. I weighed whatever I said, 0.19 or something like that, 0.1936 or something like that. So the carbon is balanced, and here the oxygens are balanced. Okay, now the hydrogens. So 4 times 2 is 8. So I have 8 H pluses here. And here I have 2 H's. So 2 H pluses there. Okay, now the charge, and this is where I always screw up. So 8 positives and 1 negative, so positive 7 and a positive 2. So that would mean I want 5 electrons on this side. And here, 0 and positive 2, so I have 2 electrons. And again, remember, I want to get the electrons equal overall. So what am I going to do? I want a common number for the electrons. Any thoughts? What's that? 10. I agree. I agree with Jonas. So I'm going to multiply this by 2, and I'm going to multiply this by 5. And that way I'm going to have 10. So when I do that, 2 times 5 is 10. And I'll have the same number of electrons on both sides. 2 times 8 is 16. 2, 2, 8. So we multiplied that first reaction through by 2. Now I'm going to multiply the second reaction through by 5. So I'm going to get 5, 10, 10, 10. Okay, now I'm going to add everything up, and this is going to be my overall reaction. So the 10 electrons will cancel out. Now, another thing that will cancel out is there's 16 H pluses here, and there's 10 here. So I'm just going to get rid of that, and I'm going to make that 6. And if you didn't do that, it would have been okay, but that's the way most people in chemistry would have done it. So I have 6 H pluses plus 2 MnO4 negative plus 5 H2C2O4. And then on this side, I have 2 Mn plus 2 plus 8 waters plus 10 CO2s. Okay. You okay with that, kind of? Okay, last thing, and then I'll let you guys ask questions, or you guys can work on whatever you'd like. So what we're trying to do in part one of the lab is we're trying to standardize the solution. In other words, we're trying to figure out the molarity of the MnO4. Right, that clear. So which means we're trying to figure out the molarity, which is moles per liter. That's what we're trying to do, okay? Well, the liters we know. We'll just take the final minus the initial. What do we have, like 34 something, point something, and 2 point something? Let's subtract those. But we got to get into liters, okay? But the moles is we're going to take this, Kylie, what was the mass of the oxalic acid? 0.19 something? 0.1993, like that. But one thing that this doesn't say is this is a hydrate. This is a hydrate. So its formula is like this. And I have to tell you that. And that's important when you find the mass. See, if I could figure out the moles of the MnO4, sorry about that, John. I got a tape in here from my other class. But I'm going to put the grams of the H2C2O4 on the bottom for 1 mole. And then I'm going to do the ratio, which is 5 to 2. And then that will be the moles of the MnO4, which then I'll take and I'll put right there. And Jonah, I'll move that in just a second. And the point in the first part of the lab is to figure out the molarity of the MnO4, which we will then use in another set of reactions. So, okay, everybody that I'm videotaping, I'm calling it a day. Hopefully that's helpful, and hopefully you watch. I certainly tried. Okay.